Hello, I'm Tom Ferguson and welcome to The Fundamental Molecule. This show explores the intersection of water, technology, and entrepreneurship. Each week, I interview innovators, experts, entrepreneurs, and investors in the world of water, helping us understand where this trillion-dollar industry is headed. These are the stories of the people building the future of the world's most valuable and fundamental resource.
Disclaimer. Tom Ferguson is the managing partner of Virgin Island Ventures. All opinions expressed by Tom and podcast guests are solely their own opinions and do not reflect the opinions of Virgin Island Ventures. This podcast is for informational purposes only and should not be viewed as investment advice or relied upon as a basis for investment decisions.
One of the reasons why working in water is fun is the people who work in it. Dedicated, driven, modest, self-effacing, hardworking, but with a lightness that comes from doing something that really matters. Craig Beckman personifies these qualities and then some. And he also happens to be working on a generational, and I really do mean that, it's once in a generation if the past is anything to go by, generational shift in the design of the spiral wound membrane module. Well, we'll go into it in the episode, but think of it as the basic building block, the workhorse of water treatment. A $4.6 billion a year market growing at 11%. Craig and his team have the opportunity to make something we all rely on, whether we know it or not, fundamentally better. It's such an exciting story, from inception to development to their enormous production space they just moved into. But more than anything, Craig is a wonderful person to spend time with. Please enjoy my conversation with Craig Beckman. Craig, it is awfully nice to see you as ever. How are you doing?
I am doing excellent, and same to you. One of my good friends, Tom. Always fun to be on a call with you.
It's really fun. I have been very much looking forward to this. And we could start in a lot of different places. It's amazing that we've known each other for, I guess, sort of 6, 7, maybe even more years by now. But my first question for you is, what did being a long-time sales lead at a very large company teach you about being an entrepreneur?
Yeah. Important to set a little context first. I was part of the GE Water Rollup, which was for large companies, but the reality is each one of those companies was a rollup. So really, we had 126 P&Ls inside of GE Water. So that brought us a lot of opportunities. The customers' problems and the things we dealt with were deep and wide and high, which was great because you got to see kind of everything from food and beverage to refining to consumer to wastewater to water. I mean, we touched literally everything. So that was a great experience to get a good sense of what are the customer problems. And it's one of the great advantages of water and wastewater treatment. There are infinite opportunities to help, because one of my former bosses had a great line about wastewater. Everybody has a wastewater problem. They have wastewater. So if they didn't have wastewater, they wouldn't have a problem. So there's always an opportunity. Another lesson I learned was kind of on that same vein, just because everybody has wastewater does not mean it's a good commercial opportunity, because there's lots of ways to clean up wastewater, which are way more expensive than maybe the way they were already doing it, as an example, or to make purified water in a different method. But the new method is so much more expensive, it doesn't have commercial viability. So that was a good lesson at that big company of not every problem brought forth by the account managers was a problem that we could pursue. Another interesting opportunity was big company, small company, new product introduction. I still remember the discussion of the chemical business that was part of that roll-up that'll be unnamed, I guess, but they were very good at adapting to customers, specifically in the petroleum space. They would come out with new products with weeks of notice. They would literally go into the lab, they'd test a product, they'd come out with a new formulation to address a problem, and their customers loved them. Well, take that same model and put it into a big company. Well, that's a new product introduction. We've got a 2-year process to do that. And frontline salespeople just lost their mind. Like 2 years, like the opportunity's gone. Somebody else is going to come in and do this. So the speed at which people can bring forward opportunities is and was a big reason I'm not at that big company anymore. I just saw too many opportunities come and go that we would have literally been the perfect company to solve, but we couldn't get out of our own way. So that was what attracted me back to small companies, because I started my career at a small company and then it got big and then it got really big when it got bought. And I'm like, yeah, I'm done. I'm going to go back to small. And I've had a great time. I've been now 10 years in startups and enjoyed my time.
That's an awesome boomerang to have been on. You mentioned we couldn't get out of our own way. To what degree do you think it's like not being able to get out of your own way versus this kind of when you're dealing with a denominator of the size that you were, the threshold for pertinency of the size of an opportunity just becomes so big that actually a whole bunch of stuff that's out there and soluble in the market is just necessarily left by the wayside. That road then leads you back to small co as well.
I still have enough contacts, and interestingly, their contacts at Veolia, which is now the latest iteration of the former company I was at. And now they're a customer of ours because they're an OEM that does solutions, and we do specialized membrane elements into those solutions. So we talk pretty often. But yeah, I know there and some of the other bigs like Xylem, project's not $5 or $10 million on a capital size. They're not interested. Or if you're doing concession work, like the Engis or IDEs or Aquapowers of the world, their minimum threshold's now like $50 or $100 million because it's just so much work to go after the project, which does leave a lot of the mid-market, commercial, industrial opportunities out there for smaller, more regional players, which I think is another fun place to be in the small companies because you can solve a problem for a set of customers and you can do it in a geography that doesn't require you to get in planes and cross oceans.
No, exactly. I mean, Aquamembranes is obviously what is in the here and now, but previously you built up the Myox Corporation. I mean, going back to this sort of experience piece, obviously you were doing your thing at GE Water. What was that experience like? Because there's such a huge advantage to doing this for the second time round. But I'm always curious about the skill set that you felt armed with to bring into Aquamembranes. What would you say?
I had a bunch of scars. Those were helpful because the next time around, it doesn't hurt as bad when you get cut. But yeah, I learned a lot of lessons in Myox on cash flow. Like when you're at GE, there's certainly lots of people that worry about cash at GE. But as a frontline sales executive, project execution, new product introduction kind of responsibility, I didn't worry about cash. You go to a small company, startup, you worry about cash as the leader every day. Even if you have a viable business, you could have a couple rough months. You got to make payroll every single week. So I think the lesson I took out of Myox that I didn't have going in was the importance of cash and how to manage that. So I think that was a big one. I think the other one was just the area of focus. Myox had an advantage when we looked at on-site generation of oxidants. Well, oxidants is a multi-billion-dollar space globally, but we were a small company in Myox, and choosing your battles was really important. And that which opportunity could you go after in the cooling tower space, in the wastewater treatment space, in the drinking water space? You can make a viable argument for all of them. Do you go with partners? Do you go without partners? Because whenever you go with a big partner, they give you access to their customers, but they're going to take some of the credit and some of the profitability. And then lastly, coming into Myox, I probably didn't appreciate enough business model. How are you going to bring your solution to the customer? Is it going to be as a transactional sale? Is it going to be as a transactional sale with a service offering following? Is it going to be truly a service? Those are critically important in how you fund the company, the adoption rate, which even markets you go after. And those were all lessons I learned coming out of Myox. And lastly, it's a lot more fun to spend the money that you raise as opposed to trying to fix issues in a business post money raised by others. So I definitely wanted to start something earlier, coming into Aquamembrane seed A series instead of post C series like it was at Myox.
Yeah, sure.
But it was a great experience. Wouldn't trade it for anything. Lots of hard things, but usually hard things lead to good lessons.
Just drilling down on that business model side of things, we often see a bit of a kind of a push and pull between what the founder would like to provide, which is usually downstream of what the market wants, which is recurring revenue. And then actually what is the sort of the best fit to the customer. We always look for people who are kind of like being super honest about what is the best fit for the customer, because there was a great example the other day where, we were thinking about like, oh, is it okay just to have a one-shot sale because you're going to like, the customer clearly like is operating in a very low margin environment and needs to spend $3,000 to be able to like purchase this box. The margins are kind of eye-wateringly good in this particular example, but there's a great sort of not doing what the quote unquote VCs or whoever want you to do. It's just really listening very closely to the customer and providing the thing that needs to be provided, even if it's not your favorite flavor of revenue. Could you just like spend a little bit of time on unpacking how you think about kind of that tension? Are you furiously kind of like customer centric, or have you found ways to kind of thread the needle by being able to like balance this tension pretty productively?
Everybody loves recurring revenue. Everything is a service, just blank as a service. Everything has to be a service these days. And that's
magic.
Yeah, that's definitely a drive from the VCs of, well, how can you make your business a service and how can you create big data of that service to then optimize it with AI? But many customers that feel like water is a critical component to their product or an extension of their brand really struggle with that. The example is food and beverage companies. We've been doing build, own, operate water treatment for 50 years, but the amount of that's made it into ingredient water for a consumer product is very, very small. But that space is one of the bigger spaces for our customers, for example. Reverse osmosis membranes, one of the biggest spaces is food and beverage, and it would be great to do it as a service, but it doesn't really align with the customer because they're really not comfortable with you taking on liability of their brand. Because if you mess up the water and even 50 people get sick from that brand, you can't afford that fix. And it's, of course, power plants and pulp and paper facilities hem and haw when they have an half an hour shutdown because the water system had a glitch. But it was a half hour productivity that they could usually make up in the rest of the day. And nobody comes back and sues you because their paper's not white enough or didn't get rinsed enough. Very different on a consumer product. So I think that's alignment. Also, we see kind of the speed issue in this big push in the industry to make everything a contract. That's, again, good for the seller of the opportunity and often does align with the buyer's long-term goals, but it's a lot harder to get the deal done. And sometimes they just need to get the deal done and speed is at a premium. We talked before about project size, same thing there. Like, if it's a big enough project, yes, everybody on both sides can invest the money into the contract and the terms and the cancellation. But if it's a small packaged water treatment system for a university or a hospital, they're not going to want the time or energy to get through that. The other great example is Caribbean desal. So that was part of the GE roll-up. The Ionics business had a ton of Caribbean desal, and it's pretty casual. Like, a guy owns a hotel in Curacao. He needs water for his guests. You've got a handshake agreement. You plop your piece of equipment there. And as long as it runs, he or she sends you a check in the mail. Turning that into a full-blown 10-year contract with take and pay and all that other stuff just doesn't work. That's not how they do business. They do business with, hey, give me a thing. We got a handshake. Maybe I'll turn it off. I'll pay most months when I can. And it's a profitable business if you're willing to adapt to how the customer wants to buy. But if you come in as, big corporate with like, here's our 50-page build, own, operate contract, take it or leave it. Yeah. The guy's like, I don't even know a lawyer, let alone to hire a lawyer. I own a hotel.
It's like, it's such a great example of really, really like deeply listening to the customer. So I'm going to take you into the world of aquamembrane. So
sure.
Before we get going, I need you to explain to everybody listening what a membrane element is, what a spacer is, and why spacers are the root of all evil and must be deleted.
Nice. I'm not sure I'd go to the root of all evil, but I am an engineer at heart and I love things that are optimized and designed well. And a spacer is not designed well.
No bueno.
We'll back up with a very personal example everybody can relate with because not everybody, but most of everybody follows or is aware of PFAS and the concern of, hey, is there PFAS in my drinking water in my home? Is it going to affect my children? Is it going to affect my grandparents? Whatever. So one very effective way to remove PFAS is to have a reverse osmosis membrane inside of an under the sink water system. So you go to one of the big box retailers, you've got a multi-stage water treatment system, says that this removes PFAS, great. I put it under my sink. Membrane is a separating device to do that PFAS removal. It's not a magic black box that destroys PFAS. Other people make it, including some of your investments, I believe, Tom. But the easiest, fastest for the big box retailer is, just separate it and send it down the drain. So the water that comes out of your tap on your sink, no PFAS. Water that goes down the drain has the PFAS. So that's an important place to start. That membrane technology, reverse osmosis, is a separating device, not a filter. So it's not 100% in, not 100% out. You'll always have two streams coming out. So as a separating device, it's going to have a flow channel. As opposed to a dead end filtration, there's no flow channel. You just run the product in and it goes through the filter media and comes out. But if you're separating something, by definition, you've got a blow down or a waste stream. And now you have a device that has a flow channel. And that flow channel in membrane elements was never optimized. The origin story, which I love, I'm not 100% sure, but I'm going to tell it. And maybe it'll just become the truth because I don't enough.
It'll become canon. It's fine.
But the researchers out in California, early days, that were doing testing on cellulose acetate membrane had to come up with a separating layer because they had to flow the water across the surface of the membrane. And the technician was walking home with a bag of oranges, and the bag of oranges had a netting material that looked like it would work well to create a little turbulence in space. So he put it in the test rig and it worked. And we started with extruded mesh spacers that for 50 years never really changed. There's some optimization in the strand angle, the strand thickness, the strand geometry. But fundamentally, if you were to stand back and look at the machine that made the spacers, a polypropylene extrusion machine, it's the same thing. And that's what Aquamembranes chose to improve on because we knew it could be done way better. So we take that layer out of the stack of a membrane element. And instead of just randomly putting a plastic chicken wire in, we come up with something that's actually designed for fit for purpose. And even more interestingly, can be modified application by application. And that's really what we're excited about. We have one pattern on the market today. We're coming out with a second pattern in the next couple of months, but it's digital. So we could make any pattern for any person, for any application at some point. And that's never something you'll get in the old design. So not only does the new design just work way better because it takes out a bunch of waste and inefficiency, but in the future, it can become so much more powerful because you design by customer, by application.
I just want to reiterate this to make sure that everybody understands. Within these big, long tubes, the separation of what's called the flat sheet membrane is done at the moment by something that literally looks like, if you put it under a microscope, it looks like chicken wire, basically.
Yep.
And the water flows through all of that and it catches a whole load of stuff that shouldn't be in there. And over time, it just degrades the performance. Just as it experienced by your customer, just really why is that crap? What is it that happens in their lives that needs to be, deleted?
We're working in an application right now. We just reviewed data last week with a customer who I can't name, but they are doing a very challenging application on wastewater. And so this is a customer that's pushing membrane systems way beyond what would have been done in the past. Back to my early days at GE, talking about wastewater, everybody has wastewater. Which ones can be economically viably fixed or recycled was a pretty small slice in the past. But that's changing quickly. And it's changing because industry is expanding and water supplies are not. Doesn't matter where you're in the world. You're in Taiwan, you're in Phoenix, you're even in Boston, someplace you'd say is more water rich, or some of the Northern European countries. All of those locations are being restricted on how much water is used for different purposes, including industrial production. So if you want to make more Coke, you want to make more paper, you want to make more electricity, you want to make more semiconductors, you need more water. The only way you get it is likely from the water you already have, which leads to higher and higher recycling and reuse rates, which leads to really difficult wastewater applications with this idea of we're going to push wastewater way beyond saturation limits. And we'll geek out a little bit here, but membrane systems are designed to be aqueous, meaning everything's always in solution. So everything in a membrane system, reverse osmosis, we want dissolved in the water. As soon as it's not dissolved in the water, it causes a problem. It's suspended solid material, it's crystals that form in the mesh, et cetera. So long path into why are spacers the root of all evil? Because if you have to push silica or barium or calcium sulfate beyond its saturation limit, you moved out of aqueous into a particulate matter in the membrane, there is no space to put that. It's a really interesting math experiment to say, all right, my membrane system that's running at a fab in Asia has too much silica in it. I'm only going to saturate out maybe a couple milligrams per liter, which is not a lot. Let's just say 10 milligrams per liter, and I'm running it at 500 gallons a minute. You start to do the math, even though it's only milligrams to start with, over a day, over a week, over a month, it is literally pounds and pounds of salt and material that you've got to shove into those housings that get caught up in the mesh material. So more than ever, customers are having to push their membrane systems way beyond what we would consider economically viable applications because they've got to recycle water further. And the further you recycle water, the more you concentrate the bad stuff on the other side. The more you concentrate the bad stuff on the other side, the more it gets jammed in your spacer, which leads to cleanings for this specific customer. They were cleaning one of their systems every single week. They had 4 trains. And so every train got cleaned once a week. So in essence, it was a 4-week cleaning time. And that's a lot of downtime and a lot of productivity loss and a lot of chemicals. And they wanted us to improve it. And we improved it dramatically. We've only been running a short while there, but the first couple months look very positive. And it's because our flow channel is custom designed to be open and it doesn't have that overlapping mesh. I mean, anybody that's seen the snow fence phenomenon where you've been driving anywhere and there's wind and snow and it builds up behind the fence. Well, the same exact thing happens inside of a membrane element in all those wraps and layers. As you shove suspended solids against it, it just gets stuck behind the fence. We don't have fences. We have columns. And so the solids just flow out through the columns and out the back end. Now, it's not a miracle. We didn't invent a perfect membrane element that never fouls, but it does, at least in the data we have so far, foul and scale up significantly slower than everybody else's.
So what has always struck me about this, and we've been in and around it, we're so delighted to be a part of this through the BIV Opportunity Fund. But what I've always loved about this is the elegance, the core elegance and simplicity of the idea, which is that something is ubiquitous within the architecture of these ubiquitous elements that are kind of the building blocks of us being able to kind of cope with treating water. There is something intrinsically silly on the inside of it that can be replaced by something not silly. But there is a lot of complexity to make that happen. I still remember the discussion about the Imagine H2O group, and kind of you guys were put in the sort of swing for the fences, like subset of the group, which is like, maybe they'll do it, maybe they won't, but it would be awesome if they did. So let's see what happens. Obviously, this is on the way to being a very big deal indeed. But what did you see that early? Why did you decide that actually this is on the right side of, well, that would be awesome if it worked, but actually this is going to be really complicated to execute? What got you to conviction initially?
Part of just, who I am, how I'm made up. Like I like challenges. One of my best motivating factors is somebody telling me I can't do something. So I'm like, yes, I can do it. Now, sometimes that arrogance and hubris has got me in trouble, but often,
but not
it
often.
has helped.
Yeah,
but sometimes. And it also was the start. Like I'm not the founder of Aquamembranes. It was started by Rodney Harrington, who has even more of that kind of DNA makeup of like, I do hard things just because people say I can't do hard things. And even coming from not in the membrane space, like he came from the nuclear weapons industry and ended up in the water space and tinkered in his garage. We were both based in Albuquerque. I was running Myox at the time. I was aware of what he was doing. In early days when he and Kevin were working on it, I was of the opinion that's not going to work. But they got it far enough along in a garage and an incubator they were working in that when we did the exit at Myox, I went and looked at some of the data. I knew we were still a long way off, but it sparked some creativity and some excitement. And if we could figure this out, this would be game changing. This would be the equivalent of the switch from cellulose acetate to polyamide membrane. Like we would have that same level of effect on a multi-billion-dollar industry. And you don't get those opportunities much in your career. Lots of people never get that opportunity to change something that fundamental. So that was exciting for me. And again, I'm an engineer at heart. I like to see things engineered properly. I love my dad's engineering joke about the glass half full, half empty. Are you an optimist? Are you a pessimist? And he said, well, an engineer says, why did they choose the wrong size glass? And we don't think about problems the same way. We look at problems and say, that's like, to me, over engineering is just as bad as under engineering. Now, under engineering sometimes leads to safety issues, and that's a concern, which is probably a bigger concern. But when things are just like over engineered and they never break, I'm like, well, that's not actually good engineering. That's just over engineering. That's not an elegant solution. And in the membrane space, we could find a more elegant solution. And then I would say on top of that, I spent 20 years on the backside of customer complaints. So very often in the GE roll-up, there was one specific job that I remember down in the Southeast, and that's as specific as I can get. But we basically sold a system that never should have been sold. We gave the customer all their money back, and it was really painful exercise. But it was based on this idea of like, we didn't know enough about how the membrane system was going to operate on that waste stream. And part of it was just, we didn't do enough due diligence, but part of it was also like the inherent flaw in spiral wound membrane elements were not going to make that job work. Now, interestingly, 25 years later, 20 years later, whatever it is, we could go back to that site with that customer and probably solve their problem now. So the other spark with getting excited to join Aqua Membranes and lead it to the next phase, besides just, hey, we can do it better, was it's going to solve a bunch of customer problems. Like I spent 20 years in the field getting the warranty calls. This doesn't work. This doesn't get to the recovery you want. I still remember a beverage co-packer in Columbus, Ohio, who called just irate in the middle of winter and said, you sold me a membrane system. It doesn't keep up with my plant. I can't make enough. I'm losing contracts. And we're like, what's the water temperature? What do you mean, what's the water temperature? We said, well, this system was designed at like a lowest water temperature of 60 degrees. And he, goes and gets the thermometer and measures it, and it's like in the low 50s because he's on a surface water source. Like, yeah, you don't make water because, you don't have enough membrane space in your system. And today, there's not a great solution to that without us. That same exact situation where a customer adamantly says to you, my water temperature never gets below this. And then guess what? They found out it does, and membrane systems don't work well on really cold water. Great, swap out with aqua membranes because we can put more area in the same system and solve your problem. So there's enough of those customer problems that I was on the other end of the call that not all of them could be solved by a better design of the spacer, but a bunch of them can.
Just for everybody listening who doesn't know how big a deal the move to polyamide membranes, just like it was a big deal. All right, it's a really big deal to move to polyamide.
Sea change deal. Yeah.
Sea change deal. And this is the same kind of thing. Any moments of doubt? And how did you deal with it? Like, were there any times where you're like, whoa, we are barking up a tree and it's really hard and we may not get there?
Sure.
Like, how did you think about those moments?
If most entrepreneurs don't have doubts at least like once a month or more often, they're probably not pushing things hard enough. That's just a part of doing startups and being an entrepreneur. You always should be pushing and breaking and pushing to things that like make it fail once in a while. I think for us, the challenge was the variety of flat sheet membrane and then also the variety of printing methods we tried. Fundamentally, the top layer, again, to geek out on membrane a little bit here, but the flat sheet membrane we start with is not actually one layer. It's actually 3 different layers. It's got a backing material, a polysulfone layer, and an incredibly thin layer of polyamide on top, which does the actual salt separation. And that is incredibly fragile. Fragile to the point that if you pick it up without gloves on and squeeze too hard, you probably broke it. That was something that we had to figure out how to run through an industrial printing process. So a lot of those industrial printing processes, part of the printing feature mechanism actually goes on the membrane. Full stop. Can't do that. Because as soon as you touch the membrane, you're likely scratching it, ruining it, etc. So it had to be something that didn't touch the membrane, but had to be super accurate. So certainly in the early days, doubts of just variation. Like we had printing method variation, we had flat sheet variation. The flat sheet manufacturers often put coatings on the material to protect it in shipment, and that had variation. So we early days kind of think 2000, 2001, definitely frustration and doubt around, we repeated the same exact test 5 times and got 5 drastically different results out of the test. And that was one of our challenges. And it's also just one of the realities of the membrane space. Like you talk to people that actually do casting and coating or making new polymers in the membrane, the amount of time that it takes to get process iteration and process discipline is important. And then just learning some lessons, which was helpful for bringing a new CTO in who had some industry experience. CJ Kurth comes from Nano H2O. And one of his first lessons is make it simpler. If you want to have less doubt and less frustration on like getting it to work, let's just be simple. One flat sheet type, one pattern. And that was years ago. And we're still doing that today. Just now, like we just got off a call before this podcast about a new product introduction that'll be happening this summer. But that'll just be really our second product, really. We've got some pattern variations in the one product, but a new product by kind of most people's standards, it's taken us years to introduce that second product based on learning some of those doubts of, is this really going to be applicable to the industry based on its variation? Like the membrane we start with, we don't make. So we source flat sheet membrane from other big manufacturers. The variance there was part of what led to our problems and some of the doubts. So my personal doubt was like, maybe we found a solution, but it's not applicable to this industry because there's too much variation there and they're not going to take their variation out. Like if I went to Toray, DuPont, and LG Chem and said, hey, could you make your product different for me?
Yeah.
No, we're not going to do that. So we had to adapt ours, which we did. And it took us much longer than we thought, as it always does. But the good news is we're there.
Just moving on to the kind of go-to-market side of things, I want to talk about getting people to be convinced about something new in the context of something as known as the RO element. But firstly, I'd love to hear a little bit about how you think about focus, because the other thing that you could do is that you could do a lot. But everyone else starting a company, it's a very good idea to not do a lot. It's a very good idea to simplify, as CJ said, right? Simplify, focus. Like, how did you think about narrowing down where this was going to be most effective, or this was going to be the easiest pathway to market? Like, how did you think about it?
I think that's another exercise in optimization. Again, being a geeky engineer, it's, what is the right solution? And I often with my team go to the extremes to say, all right, one extreme on focus is we have one product, one pattern, and one customer, and that's it. And we get good with that customer. The other one is lots of patterns, lots of membranes, as many applications as you could find. And neither is probably the right solution for most companies. And you're going to have to optimize between enough customers that you've got some variation in one backs up the other when things don't go as planned, but not so many customers that you can't be effective with the ones you have. So right or wrong, we've landed on 4 end uses in North America. So we've got microelectronics, food and beverage, mining, and industrial water reuse. So in those segments, that's kind of our area of focus. You could maybe argue we should be in 3, not 4, but maybe that's my hubris again coming out to come to 4. But I think you just need to, as you're building, be really disciplined and honest with yourself of, am I actually keeping up with this customer? Do I have the expertise on my team to stay with this customer? For example, one for us in the microelectronics space is they have a lot more documentation requirement. They have a much higher expectation of quality than a mining application does, for example. So microelectronics probably wouldn't have been one we chose initially, except that we had a core customer in Micron as one of our investors. And they said, we're going to invest and we're going to install it. And that helps us with the rest of our go-to-market strategy, because if you've gotten through and actually sold the microelectronics customers, then power customers, pulp and paper customers, petrochemical customers, mining customers, all in general are more comfortable. Now, they still have to be convinced themselves. They still want to see the data, and that's important for us. Another big advantage we have on the go-to-market is our product is so interchangeable, and the risk to change and change back is pretty low. So it's not like we got to bring in a whole skid-mounted trailer system to demo something on their site. If they have a spiral wound element running, a system that's got 20, 30, 200, 2000, whatever it might be, we simply swap them out, turn the pump on, and the energy savings is either there or not. So the first value proposition we offer, they find out in days after the switch. And if it's not there, we have often said, switch back. Just pull your elements out, put ours in, hit the pump. The energy is going to be there or not to what you used to do. And if it didn't work, then swap back. To date, nobody swapped back. But that does help us to be a little bit more, I would say, bullish on the go-to-market, because the membrane elements we're supplying are interchangeable and a bit of a commodity, even if the customer application is very different. So making ingredient makeup water for a beverage is very different than concentrating lithium. But interestingly, the product to do both those things is the same. So your team is going to have some knowledge in the customer application, some experience there to talk the right language and understand their needs. But from the product standpoint, we don't need to change the product. Like our product can go and do semiconductor rinse water. It can do makeup for bottled water. It can do lithium concentration, and it can do high purity water for a power generation application. So that helps us on our go-to-market to be maybe a bit more in more buckets than maybe other companies are.
As you build these case studies, how do you think about the kind of the virtuous cycle that gets created? Because kind of academically, what should happen, right, is that if people haven't read your Micron and Osmoflow case studies, please do. They are eye-opening. But over time, do you imagine that decision is going to get simpler? Because one of the things that can happen is that people sort of think, oh no, our beast is radically different. And of course, what worked over there is not going to work here. Like, how do you anticipate that convincing cycle changing over time as you build out into the market? Do you think the switching costs are going to go radically down? Or do you think people are going to be consistently dogmatic about the performance and, wherewithal of their particular system?
I think, there's a tipping point, an inflection point. It's kind of the cliche, but I think it's a cliche because it happens, that there's going to be a time where customers are going to need to see the data themselves. They're going to want to run the system. They're going to want a lot of monitoring. They're going to want internal testing and monthly meetings to look at the data to convince themselves, A, they got the value we told them, and B, the value is maintained, which is really important in the membrane space specifically. There have been a lot of solutions in the last 20, 30 years where right out of the gate, it looked awesome. But 6 months in or 8 months in or a year in, it's like, the value you said. And interestingly, right on spacers, there was another manufacturer years ago that was putting a coating on the mesh spacer to try and keep biogrowth down. And they were selling it at a premium. And they found over time, it just didn't continue to work. It worked great in the beginning, but then it fell off and it didn't continue to work. So there's going to be certainly a time for customers to say, not only does it have to work for the first week, which we can see the energy savings, but we're going to run it for 3 months, 6 months, 9 months, a year through a number of cleaning cycles to actually see if you get the value. But there will be that inflection point where there's enough talk in the industry, there's enough talk across their organization, there's enough discussion from A&E firms, engineers that they talk to, that it will become just aqua membranes works. Every person I talked to said it's fine, just trust it. I didn't know why this analogy came into my head, but indoor plumbing. My father grew up without indoor plumbing on a farm, which is a funny story. But when indoor plumbing started, like a whole bunch of people like, oh no, that's never going to work. That's never going to work. Like your house is going to be stinky. I can't believe you're going to bring an outhouse in. There's a huge adoption curve. Now you're building a new house. Nobody ever asked the question, oh, are you going to have indoor plumbing or outdoor plumbing? We just all accept that a toilet works great. And at some point, like printed spacers will be that same thing of like, nobody asks, hey, does it really work better? It's just the thing to do because it's the better design and you don't have this. Now, is that going to be 1 year or 3 years or 5 years? That's our team's job. Like I view that as a huge part of our job is to accelerate that and to do compelling case studies and to do the go-to-market strategies and even the strategic investors we bring on. We've got a cap table that's got both financial investors as well as strategic investors with a recent sign of Osmoflow in Australia. I'm headed over there in a couple of weeks to kick off with a roadshow. But I love what Osmoflow is doing in the mining space. And they're pushing those limits. And that's going to shorten that adoption curve. As more people see what Osmoflow does with their solutions, and maybe they lose a contract to Osmoflow because of the solution creativity they're doing, that speeds that adoption curve where people are taking a risk with us because it helps them in something they want to do. Win a contract, meet a sustainability goal, whatever it might be. So the tipping point will come and our job is to get it here quicker.
Make sure it's as soon as possible. Absolutely. Well, one of the things that will help get you there is obviously reducing your unit costs, which is why you've taken on a really spectacularly large production facility. People very rarely talk about this. Like, what is the process of standing something up like that? How have you and the team thought about making it real?
Yeah, and maybe answer even like the why part of it first before we get into the how part.
Yeah, perfect.
We have a lot of customers that are looking at our product. One of the questions very early in the piloting is like, what's your capacity? We're not going to put the first 50 in until you show us when at some point in the future you could supply 5,000. Because we're not going to get all interested and excited about this if you can't actually meet the need of our whole organization, which is expensive. because it'd be much better to build a plant that makes 50 and then 500 and then 5,000. And jumping from 50 to 5,000 is a big jump. So that was part of the why. The how is having a good team really helps. We've got CJ on the team that's scaled up membrane plants. At his last startup, we brought Syed on, who's scaled up not necessarily membrane plants, but water treatment technology plants. I do not have that area of expertise. So mine is setting the vision and holding them accountable to a schedule. And then theirs is negotiating with Knox County to get the best incentives we could get, getting the building plans pushed through quickly, which we've actually been able to do. And then back on me is a little bit of casting the vision of what could this facility be, which is why we ended up in a facility that's meaningfully bigger than we need to. But line 1 will go in, it'll be operational this summer. We have room for 5 more lines behind that in that facility. And it wouldn't be difficult to cookie cutter and add those. And we really view this first as a showpiece that we're going to expect customers to come to us and say, look, we buy our membrane elements from a multi-billion-dollar company that's been around for hundreds of years. You really want us to switch that buy to a smaller tech company based in Albuquerque? When we have that facility in Knoxville up and running at quality, at quantity, we've got statistical charts that show our yield, our rejection, our testing methods, et cetera. That helps de-risk that a lot. And again, accelerates that tipping point, adoption curve, whatever you want it. So yes, did we build a facility that's a bit bigger than we need for the next year or 2 years? For sure. But is it a bullish outcome? Yes. But even then, like if we built those other 5 lines and we're running 3 shifts out of that plant, we're still under 5% of the global membrane market. So it's big for us, but when you look at the whole global spiral wound membrane element market, it's actually not that big.
Which is kind of a handy segue to what that made me think of is that this is intrinsically a bet on kind of the membrane market remaining at the basis, the fundamental element of being able to deal with a whole bunch of different wastewater streams. How do you think that, imagine, the listener is somebody who's relatively new to the membrane market. How do you think that they should think about the forward-looking prospects for membranes? What are we looking at as the major shifts that are coming?
I think an interesting one would be the editor of GWI, Chris, did a presentation at I don't know where we were out in Palo Alto about a year ago, but he put a slide up that showed the Central Valley of California from the early 1900s and currently, and it's night and day. Like it is literally a desert to a Garden of Eden. Saudi Arabia has basically the same aspirations. They want to turn a big swath of that country into the California Central Valley to grow almonds and strawberries and lettuce. The only way to get that done is with inexpensive power that's renewable and membrane technology. And if we look at solar as an example and the price at which solar's come down from the equipment side based on volume, that could be a leading indicator of global adoption of a product like that turns arid places into not arid places. When you've got the money and the resources and the drive like a country like Saudi Arabia does, and then you look at a country like India and the global warming issues we have, parts of India regularly get to 120, 130, 140 degrees Fahrenheit. Really hard to keep water sustainable, especially if you're using surface water in those kind of temperatures. They run out of water. I see membranes as a critical need for both of those, which is food security, water security, which are just fundamental to being a good human on Earth. And then lastly, the economic drivers. If you've followed the news today as we're recording this podcast, everybody's wigging out on tariffs, which is very central to people are very selfish when it comes to economic development. They want the economic development in their country, in their state, in their county, in their city, whatever their view of the world is. And economic development runs on water, and the water's a limited zero-sum resource. And so using it more effectively is important. Membranes, I think, will be a key. I know membranes will be a core component of that cleanup. Even as other technologies come along, coagulation technologies, electric fields assisting new types of polymers on the membrane surface, but fundamentally a polymer membrane is going to be at the heart of so many of those things. Ceramics will catch up on certain areas for sure. Flat sheet membrane forms. And that's just in the water space. Like we're starting to see inquiries into other separations in gas applications, for example, which is a whole nother podcast. But yeah, membranes are here to stay. They're going to grow. They're going to grow at 2 to 3 times inflation for a long, long time, hundreds of years into the future.
This is seriously exciting. I knew this was going to be good. Craig, you're a legend. Thank you so much for being here.
Sure.
We've only got time for our final question. Really appreciative of your time. As ever, it is the same final question as we ask all of our guests. If you had to choose one piece of advice for current and future water entrepreneurs, what would it be?
I think the one piece is persistence. Water is a super interesting place. It's super rewarding. You can make a lot of money here, and you have to be persistent to do it. The analogy that I was thinking of as you're thinking of that question is the Grand Canyon. That water flowing through that canyon at a very slow rate over time created something magnificent. And water over time is going to do something magnificent. So be persistent, do hard things, and stick at it. Don't pivot too soon. Stick at it.
Superb. We'll see you soon. Thank you so much for coming on The Fundamental Molecule.
My pleasure, my honor. Thanks, Tom.
Cheers, sir.